Hey guys, welcome back to the channel. Got something new today. Yet another project. About project out. Got to get ready for hunting season. This football crap for the sports for our radio station is about to start. Gonna be busy with all that mess. But you know what the heck? Take on another project. But let me show you what we got. It's in this box from eBay. Fragile, handle with care. That'll make them quit just using it as a football, won't it? Let's see what I got. Put y'all on a little mini tripod here. Point you down. And find my cutter of choice. Alright, let's see what we got here. Let me point that up. I really love this mini tripod. Let's see what we got. What we're going to name this episode? eBay find. Will it work? Does it work? Is it in one piece? Did FedEx destroy it? Is it going to be all busted all the heck and back? Who knows what to expect? A lot of packing material. Not sure what this is going to look like. It is upside down. The most best packed thing I've ever seen in my life. Alright, here we go. Well, that's not a good sign, is it? Styrofoam. I hate styrofoam. If this thing's intact, oh my gosh. If this thing's intact internally, it'll be amazing. Well, it's a B&K. Yet another B&K piece of test equipment. Imagine that. B&K Model 1460 oscilloscope. Just like the one I used to have at my TV shop that I used to work at. So I'll have this and that. And that dude up there. I have 3 pieces from the shop to duplicate. It's missing this little knurled nut right here. Stupid styrofoam. I hate styrofoam. But there it is. So let me pause here for a minute. I want to clean all this styrofoam off here, and then we'll take a closer look at it on the outside. Then we'll open it up and see just how bad it is, and we'll see if the CRT is any good. Alright, I got it cleaned up. Let's have a look at a little closer at it. Yeah, I wiped it. It's still got some more stuff on it where I wiped it off here, but 5-inch CRT. I don't have a clue if it's any good or not. Let's see, you got a 5-volt peak-to-peak calibration signal here. There's astigmatism adjustment right there, intensity focus. Sync normal, TV horizontal, TV vertical, internal, external line sync, plus and minus slope, typical. Sync triggering for most oscilloscopes. External sync and ground. Here's your trigger level and stability right here. Ground, vertical input. Uses a UHF connector here. It's a DC ground AC. Here's your time base right here. does turn your position left and right, or horizontal, a vertical, your vertical sweep, vertical gain control, your illumination right here, your pilot light, and of course your CRT. Yeah, you see what's on the bottom of this thing. Lord knows what this is going to be like. Let's see, got your patented handle on the back. Let's see, there's your, yeah, I forgot what that's called. Let's see what the line cord looks like. I just got an intact line cord. Yet more. Oh, I got to get a vacuum cleaner out here. Good Lord, I hate this stuff. There's going to be some inside. Yeah, it's an intact line cord. Can't believe that. So let's open it up. I really like that little mini tripod. If I said that once, I'll say it 1,000 times, I guess. Oh, it's got two little Phillips head, or whatever. It looks like a Phillips head in there, and then I got another flathead screw there. So, yeah, is this thing worth? Did I make a bad buy? A little cranky this afternoon. They cross-threaded the damn screw. Good Lord, yes. Yes, they did. Oh my gosh. They took it apart for pictures. And when they put it back together, they cross-threaded the daggum case screws. Oh my Lord. Didn't know it was going to take all day. Probably can't see it not, but I'm walking around without my boots on. I just cleaned the shop, so I'm safe. I ain't going to get nothing stuck in me. I'm going to do all this stuff to an isolated transformer, so I'm not worried about electrical shock. There's the insides of this thing. There's a little rust on the bottom of it. That doesn't really scare me though. What scares me is where it come from. There's the lid, the inside cover. You might taking a chance, man. Let's have a look at the circuit board there. This will clean up. That's not a big deal there. I can take these off. That's not a problem. You know, like, let's see. Get y'all widened out a little bit here. Straighten this up. Not that bad. I mean, internally, there's an oil-filled capacitor right there. Make sure that's not seeping, but that's an oil-filled capacitor. And then here's a filter capacitor right there. Here's the high voltage capacitor. So there's the the regular filter capacitor. Circuit board right here. That's probably got the high voltage and circuits on it and stuff. Anyway. Oh yeah. That's like a candidate for the ultrasonic cleaner. Power supply transformer. Look around a little bit more. It's not bad. I mean, if it works, I can make it work. You know, we fixed radios with this kind of mess before, so I'm not too worried. The CRT, that's the thing. We won't have to check it to make sure it's good. So let me yeah, that board's a little on the nasty side. That looks like he probably, I'm thinking vertical deflection. It's either vertical or horizontal deflection, one of the two. Look at all them little capacitors. Ooh-wee. Transistors galore, holy moly. That one's been cut, tacked back on, so that's not a good sign. Oh well, let me pause you a minute and figure out what the number of this CRT is, and get to see if we can find it. Get the CRT tester to test it. So, okay, this is a this CRT is a let me see here, a 13ARB1 right there. Universal adapter, scope. Then we have to set all this stuff up right here. So let me get all that set up and then we'll test it. I don't know how this is going to sound. Okay, anyway, there is the CRT. It's a 13OARB1. I'm sorry, 130 ARB1. I'm sorry. And I guess it's 130 mils across. Anyway, we got it set up according to the setup chart. So, I'm going to turn, see, the bias is supposed to be minus 68. So, set up for black and white right here. And then, let's see here, 3, 4, 5. The universal set, so F1 and 2 should be, F1 is 1, F2 is 2, and then 3, 4, 5 is usually how this works. Turn the cutoff down, filament down, minimum. Alright, let's turn it on. We're going to do the filament set. First thing we want to make sure this thing ain't got a little atmosphere in it. Filament set at 6.3 according to that. Fit the lid up, I don't see it. Let's see if we can get some cutoff. Heater to cathode, short's good. See if we got any cutoff. So as we do. Wow, could this thing be good? Wow. It's amazing. That is good news for a change. Let's turn the filament voltage down and see if that drops down. Yep. That is a strong CRT. See, I've got the filament turned all the way down, and it's just now dropping just a little bit. Yeah, I got the filament down to 3.5 volts. Bring it back up. Ah, thank the Lord. That is a good CRT. Even if I can't see the filament. Alright. I'm really tempted to plug that thing into the dim bulb and let's just see what happens. You want to do that? I believe the CRT is good. No problem there. Let me get this out of the way and we'll hook it on the dim bulb and see if this thing actually comes to life. Wouldn't that be amazing? Alrighty. Here we go. Let's see what we got. Intensity all the way up. Focus. About mid-range. Okay, we'll leave it there. Turn it on. Illumination. So I have my dim bulb tester connected into my Variac isolated power supply. I'm going to turn it on. Let's bring it up. Not drawing a lot of current. I'm at about 80 mils. Dim bulb's not showing a whole lot. Do have illumination right here. That's a good sign. Not drawing any appreciable current. I get about 120 volts. Still not drawing a lot of current there on the meter. Illumination's working a little bit. Don't know about the power supplies though, as nasty as these things are. It ain't drawing a whole lot of current. Got it up to full line voltage. Probably don't need to run it like this very long. Don't know what that high voltage transformer is doing back here. Let's turn it off for a minute. The thing I like about this, everything is written on here. 1000 volts here, 160 DC, 40 milliamps. I like that. That's a secondary, 30 volt secondary. 6.3 at 0.6 amps, DC 3 milliamps. So 1000 volts at 3 milliamps right here. Two orange leads. That looks like a resistor. I'm not touching it. Resistor that don't look too good right there. There's your diode stack right there. Two orange leads coming out of the transformer going somewhere. Yeah, there goes one right here, there, and the other one going to this diode stack. So how do we want to proceed? We'll turn this voltage all the way down. We'll hook up the triplet to it. So let me get that done and we'll be right back. Alright, so I got my triplet 630 right here. Connected, set it for 1000 volts AC. And I've got it on the high voltage secondary coming out of the transformer. So I have my power supply, my variable AC power supply, turned down to minimum. So we're going to fire it up. I do not see any B plus, nothing. It may not be a good thing. Didn't see anything. Probably because it's turned off. Let's try that again. Now there we go. Now we got some power. So we do have a good secondary transformer. It's just not no 1000 volts. Let's see, it's more like about 600. So I have a feeling right there, it's the calibrated line voltage, and it's putting out a little over 600. Chances are there's a short in that high voltage. So let me go in here a little bit safer and see if that cap's got any charges. I'm going to pull one lead of that secondary loose, and I'm going to see what it does, open circuit, and we'll go from there. Because if that thing is bad, then this is a no-go. Okay, here we go, round 2. I've got the diodes, the rectifier diodes disconnected, and it's simply the primary, or I'm sorry, the secondary of that transformer now. So let's do this test again. Now, it could be the voltmeter was just wrong. I decided to use it. Let's see what happens. I'm going to turn it up. Showing still about 630 volts AC. I don't know if that's accurate. So let's go ahead and put it in bad boy right here. We'll put this in AC mode, 2000 volts. We'll transfer this just to make sure. Alright, here we go. We're going to do it again. Oh yeah, my triplet ain't working right. That shows 980 volts. That's more like it. So this thing's not right. Imagine that. Who'd have thunk, right? Yeah, I guess that's another project for another day. Anyway, high voltage secondary is working. Put some rectifiers back in. That's all the time I got for right now in this segment. It'll be a fun little project. Need to make sure the high voltage is working. We got high voltage. You need to make sure all the secondary high voltages are working. Probably need to look at, let me get this out of the way. Probably need to look at cleaning these circuit boards off, which means I may have to take this one off and just, oh yeah. This may be oh my word. Y'all see it? No, you don't see nothing but that flashlight. If I can balance this. Let me zoom in a little bit. Ah, you piece of crap. Saw it there for an instant, didn't we? Look at that transistor. Look at that transistor right there. OMO. I can't get nothing to work today. Nothing wants to work. That transistor there got a little green growing out of the legs. Don't know how many more is like that. I don't know. We'll figure it out. Let's just totally run it. Don't know the old Elnas. I bet you these things ain't very good. I think it's been outside. The CRT is fine shape. That's giving me the high voltage transformer seems to be okay. CRT is good. Now I haven't checked this 160 volts. Let's do that real quick. So let's go ahead and check the 160 to make this. That should be the deflection circuit right there. So 308 volts. So that's good. Again, I'm doing that with my socks on, but that's keeping me protected. So I know the 6 point, well, I guess we could check the 30 while we're at it. That's the filament circuit right here, these two green ones. Let's check this 30 volts. I believe the transformer's going to be okay. Yeah, 30 volts. Or is it 60 volts? Yeah, it's showing 56, whatever that means. well, I wanted to work on this more, evaluate it a little more, but I think I think the next step in this thing is cleaning it. I think we need to take this board off right here, give it a good ultrasonic cleaning. All these capacitors here, oh boy, nothing in here that can't be replaced. You know, we'll have to check everything. We'll take this board out, clean it, check all these electrolytics. That'd be one thing to do. Sweep board gonna be a little different. That board there looks like not gonna be easy to get to. What we'll have to do is take the CRT out to be able to get to this board good. So we'll probably have to take this out and give it a good washing. And then we can go in there and look for corrosion and everything and replace whatever's corroded. And we can get it working. We can do it. I think that's the biggest thing, is just getting it clean again. I'm sure some of this stuff is not good. Alright, we're continuing on here. I got a couple more minutes to spare, but I gotta go here just a minute. It's been left up to me to cook dinner tonight, so I'm gonna have to run up the store. Anyway, I got the CRT. I'm going to take the CRT out and I'm going to put it over here out of the way. So what you have to do is just take these 4 knurled nuts off the front of this, and this whole piece, this whole little section comes apart. Well, I really like these scopes. Anyway, we know this is a good CRT, which is just really... Let's see, ESO number something other 39 of, oh I'm sorry, 34 or 9 of 76. Which we drop it. There's your number right there. Yep, that's 130 ARB1. Made by Toshiba. Toshiba. That over there out of the way. Now that that's out of the way, we can take the shroud off and screw here, here, and here. Like that. Actually, not the shroud, but the magnetic shield. What keeps the magnetic field of the Earth from interfering with it. Man, I could work on this thing all evening long. I didn't have everything else I had to do. What I'm trying to do is get to the other circuit board. One thing that I'm going to have to do though in this set, or in this scope, I don't know where that went. Let me grab it. I'm going to have to invest in a wire wrap tool, because everything in here is wire wrapped. So for me to work on this, I've got to take, like this board's got to come out. Just very carefully. There it is. There's your magnetic shield. And it needs a little TLC. It's been rode hard and put up wet. I think this one was outside. Oh boy. I think this was a barn find. I'll tell you right now, we're going to need some transistors, and we're going to need some capacitors, and we're probably going to need some trim pots. Yeah. But we don't need a CRT or power transformer. That's the good news. So, this is going to be fun. Let me show you what that PC board looks like. Oh my word. Here we go. Zoom in a little bit. Couldn't even begin to tell you what the devil that was. I ain't sure how a rat would have got in here, but it sure looked like it's been a mouse pee. Don't know how they would have got in here though. Yeah, I do. Right here. Yep. That's what the deal is. There it is. They got in through this hole back here in the back and got in here. That's exactly what that is. Mice. I'll be daggum. I didn't recognize that. I probably wouldn't have bought this stupid thing. Yep. See that hole right there? It goes all the way out to the back of the oscilloscope. Well, so we got a demice situation, and I should be wearing gloves. So it gets a bath. It's going to get a bath, and it's going to sit outside in that shop for a while, and till it dries good. Don't think I'm going to take it apart because there's just too many of these wire wraps. You know, I'm going to have an issue with these things like these right here, that wire wrap right there that's corroded. So we'll have to address that as we get to it. All of them are. Gonna be a good one. There you go. Till next time. I couldn't help myself. I had to pull one of these capacitors off this main board right here. So these elements that say 220 microfarad, 50 volts. Got it right here in the tester, but a Syncor says the value on a 220 is 256 microfarad. Remember, anytime these things show high, it's got leakage. Just the way it is. Checking leakage. Right now it's a 52 ohm 52K resistor. Now it's checking good. Could be reforming though. You know, a lot of people like to say that. It is going up. I mean, you know how I feel about reforming capacitors, but let's check it on bad boy here. I gotta get my adapter. Whatever I did with it. There we go. Yeah, I gotta get out of here. I gotta go cook dinner. My wife wants homemade spaghetti, so I just gotta go dig some deer meat out of the freezer and. Alright, here we go. Let's see, it's 220. Yeah, it's electrolytic. Here we go. It's just. Oh, by the way, I ordered a 1629 for this. So we're on a 20 to 1000 scale. That would be this guy. So it's reading about 300. We'll go with that. Let's put it on 150 volts. Do a leakage test. Look at that eye. It don't, see, this thing don't lie. I love this old capacitor tester. This thing wants to be like very sophisticated about it. This dude tells you like, yeah, it is, or no, it ain't. Actually, I'm overdoing it. Ain't a 50 volt capacitor. Good Lord, Sam. No wonder it's leaky. Brain dead this afternoon. There we go. Now we're okay. Oh yeah, it's under 25 volts. Yeah, that's good. I mean, heck. I'll leave it in there. Let's call it innocent till proven guilty. How about that? Well, anyway, this thing's going to need a cleaning. I wish I could get these boards out, but I'm going to have to probably just clean them locally. Try to keep water out of the controls. All I know to do. But I ain't got no more time. I gotta go. Alright, it is Thursday afternoon and I'm back working, kind of jumping around on working different things, so this video is going to be wild. You know, I'm back working on the B&K 1460. I went and cleaned all the mouse residue off of this thing yesterday. I cleaned those circuit boards really. I used 409. I just sprayed it directly on the circuit boards, let it soak a while, use a camel hair brushed in there and got them all good, and then it still has corrosion on some of the areas. And something y'all ought to try, like it uses a lot of wire wraps on these board connections. It's, you know, like a lot of Japanese type sets do. But try using vinegar on there. Just put a little bit of vinegar, pour you a little bit of straight cleaning vinegar on there, leave it on there for about 3 minutes, then take and wash it, and then wash it back off of 409, and then wash it with distilled water and dry it good. It will get rid of that corrosion that's on those wires. Amazing. Anyway, I've got it back on the bench. It's not perfectly cleaned up. All the metal rails on this thing I still have them out there in my other shop. I'm going to have to, I've got one of them soaking in vinegar right now. But I didn't realize yesterday when I first opened it up that was mouse pee and stuff. I thought it was just incidental rust, you know, might have been sitting outside or something. But no, it was mouse. Where the cord goes into the back of the set, let me show you. Where the cord goes back in the back of the rig right here. I wonder how in the heck did a mouse get in here? Well, there's a big old hole here. Don't know what that hole's for, but that's how they got in there. They went through this cord hole right here and got right in through there and made them a nice little house. And there was some bunch of straw or something right in this area here. But I got that circuit board pretty shiny. This is the one that was really filthy right here. All that cleaned up. That's all these connections here were green. They all cleaned up really good. So I don't know what the vinegar would have done to these capacitors. I hope nothing. I hope, but we'll find out. I did pull one cap yesterday. This 220 at 50 volt Elna. It checked good. So I'm going to put it back in here, and then we'll. I'm going to apply power to it. And I've got the high voltage, I've got the power supply right here, so I'm going to check the high voltage. I'm going to check the high voltage here, and I'm also going to check the low voltage circuits to see if all that stuff's working, and just go from there. Who knows, the thing might actually work now that I got it cleaned off. So let me get set up and I'll bring it back. Alright. It's just got the capacitor back in, right orientation. So we're going to lay this thing back on its belly here. Let me turn it around a little bit so I can get to everything. Oops, got to turn it around. Give me, bear with me. All my ducks in a row. I don't have the CRT in yet, as you can see. Just got it out to where I can get to it. Still missing the rails. I got to put the high voltage diodes back in. Got to put them back in. Then we'll check this bad boy. It's got a bunch of test points on it right here. 25 volt rail here, things like that, 31 volt. Got a bunch of voltages on here. So let me get these put back on, which I've just forgot about. I just saw them as I was talking to you guys. And then we'll check the voltages here and see if this thing is actually generating voltages like it should. And let's see if we can get some sweep out of it. If we get some sweep out of this thing, we might put the CRT back in it and see exactly what else is wrong. So, be back. Alright, for better for worse, here we go. There is a low voltage rectifier, which is right here. 2 diodes. It has an orange wire that goes over to this filter cap right here. Let me find a pointer. What I'm basically doing, I'm just going to look to make sure the power supply is fine. Basically, if you can, where am I? I can't see nothing with this stupid thing. There is the here's a high voltage secondary right here. We'll get to that in a minute, but at least I think I will. Right here, here's the B plus power supply right here. There's two. It's a full wave rectifier here with a center tap ground, and it goes into C128 47 at 315 volts. Goes through a 470 ohm 2 watt resistor through another capacitor. Goes through a 820 ohm 2 watt resistor through another capacitor. So 347s at 347 microfarads, one at 315, the other two at 250. But basically I'm looking for 172 volts out of an 820 ohm resistor. So it's over here. So I'm just going to turn this sucker on, bring it up, and I'm going to see if this thing is even generating high B plus voltages, and see if making sure that it's jittery as a dog this afternoon. I don't know what's up. No, I mean, don't know how the cleaning this thing's gonna like. Don't know how this thing's gonna like that cleaning I gave it either yesterday. They may go up in a big puff of smoke. All right, we're on volts. We're on 200. Go up to 2,000. All right, here we go. Will it work? Will it blow up? Here's the rectifiers in question right here. So far I have 118. I'll bring up full power. I'm at 184 volts right there on the input of the filters, which that's good. We'll go through two more resistors. So there's 1, 2. So we're going to go over to that. I have 123 volts, which should be 172. There's 172 right there. So let's see. What are we starting with here? 183. Alright, and then it's going to 170, going to 122. So that's our first issue right there. Why is it so low? And that goes into, that feeds the vertical deflection board. Go figure. C11 is a 22 at 250 on there. It's the first thing it goes to. So either something's loaded down or we got a capacitor that's bad, riles about.
Give me that low.
Let me see if I can identify the red and white wire. So I got to flip this thing over. So let me turn it off. Let's see if we got some high voltage on this bad boy. Let's do that real quick while I'm in the mood here. Not sure how much high voltage this thing should have. Let me see if I can figure out where it comes from. Let's see. One diode there that's transformer is right there, goes into that yellow wire, which, yeah, I'm going to touch it right now, but here is high voltage right here, coming to this point right there. So I'm going to measure that with my VTVM, and it's set for 1500 volts. So let me get it set up. VOM or VTVM will take that surge a lot more than this guy will. So I'm going to just turn this down, turn it back on. Well, I'm at 30 volts input and I've already got 720. I'm at 85 volts and I've got 1300 volts. I'll bring it up a little bit more. So I'm at 75 volts primary voltage or AC voltage, and I've got 1500 volts coming out. So I already know that this is probably okay. Yes. My high voltage seems to be alright in this thing. It's just my low voltage is not right. So what I'm going to do, I want to flip this thing over, and I want to look at, show you guys what I'm trying to say, if you can understand and keep track of what I'm trying to say. It's hard to read this. Anyway, this is my output right here of the B plus, 205 volts right there. Goes into C128, C127, and C127 again, the 247 at 250s. And what I'm looking for here is 172 volts, and I've only got 125 or something like that. So it's either going to be a problem with this resistor or that cap or this cap or something on this board. So I'm going to flip it over and find this test point 14 and pull it. Then I'm going to see if I get my voltage back, and we'll go from there. Does that make any sense? Somebody tell me. I don't know. All my clip leads off, test leads. Red and white wire comes up here to 30 into that big dude right there. You can zoom y'all in a little bit more. There we go. So this is the next one, and it is warm. Now, I don't have a wire wrap tool. What I think I will do, I will own this out real quick, see what kind of resistance is there. I don't want to unwrap that because I don't have a wire wrap tool that I remember. Well, what kind of short's going to be on there when I have, well, I got 7.5 volts on it. Had some kind of short on there, seemed like it wouldn't do that, right? What's going on here now? In 500 volt scale, I'm still reading about 120, yeah, about 125 volts. So if I turn it off, the voltage just drops away slowly. It's odd. I think it's because one of the other power supply filters ahead of it, I'm unwrapping that right there. I know I got a wire wrap tool somewhere. I haven't used it in decades. The thing about it is it's in there. Careful where I poke. Tell you what, my hat's off whoever did this wire wrap. Yeah, I know. Alright. See if I got my voltage back. That'll tell me a lot right there, just connecting that right there. Yeah, it brought me up to 200. Turn that back off again. Let's get our amp meter put on there. This guy here. See what kind of current draw that thing doing. Oh yeah, it liked that. Fire in the hole. Well, 100 mils, it ain't drawing a whole lot. Wondering if we just got a bad filter resistor. That's what it's acting like. 125. It went from 125 to almost 200. I don't know. We had 172. Let's figure this out. Supposed to be 205 coming out of there. So let me go back to that. Get rid of this for a few minutes. I figured that thing would have been drawing boodles of current. I don't know, man. Let's get back on the other side real quick. You know, this video is going to be a lot of this right here. How about I stop you guys, let me find it, instead of y'all sitting there watching me do this boring crap. Let me see if I can find where the problem is, and when I find the problem, I'll let y'all know instead of y'all watching me do this kind of stuff. There's going to be a lot of this with this oscilloscope. So, I'll be back. Well, this is becoming about as much of a nightmare as I figured it was going to be. The schematic that I have for this 1460 is incorrect. It is not the right schematic for this version scope. So, there is no shorts. The filter capacitor checked good. It's telling me I'm supposed to have 172 volts on there, and that is incorrect. So I'm going ahead and running with that. I'm going to call it 120 volts, 125, 127. But what I want to show you is, well, I decided to check functionality. Okay, let me zoom you in a little bit. I want you to watch. I'm still in the vertical deflection stage. Okay, I'm still in the vertical board right now. Let me move this out of the way. So anyway, I'm on the vertical plates here to the CRT on the vertical deflection amps. If I can do this without shorting something out, that would be just amazing. Now I'm going to adjust the vertical position. I'll adjust it one way. It goes up to 65.5 volts. It'll come down to a null. Go back the other way. About 72. It's not 100% balanced on the ends, but that section of the circuitry is working. And I'm tempted to throw a tone in the front of this thing and see if I see a signal there. So that's what I'm about to do. I'm about to put a signal in the front of this thing, and I'm going to look for a signal on the output of the vertical. Basically, I think what I'm going to do is just check this with the vertical. Not with the vertical, what's the matter with me? Just the calibrate signal. I'm going to take my probe right here. I'm going to go up to this scope. And I'm just going to hook into my 5 volts calibrated signal. Well, I'm going to look for that same signal. Well, crap. Use my scope lead. Boy, I'm so dumb. I'm so dumb sometimes. Anyway, let's see. Let me get all this crap set back up. Alright. Where are you? Where is my scope? Alright, right there I'm feeding the calibrator signal into the input of the scope under, or the device under test, okay? If that makes any sense. I'm just going to measure the output deflection amp see if we get anything through this. Yeah, it ain't the best in the world, but it's there. It is there. You got some functionality here. It's mighty noisy though. That's on one side of the vertical deflection. It's on the other side right here. Noisy, but it's there. That's not a bad thing, actually. I'm not sure why it's noisy. We'll get to that. That could be anything. We can trace it through here and see where the noise is coming from. It could be one of these transistors are just bad. But that's not bad at all. There we go. Get this out of here. So let's look at both sides of this thing. I'm going to look at both deflections. I'm going to activate channel 2. There we go. See, they're mirror image each other. So see, the stage is actually working. This is what the CRT, that's how it deflects using the electrostatic plates. This is one side of the vertical amp, this is the other side of the vertical amp. So that's working. This section's working good enough to move on to the other section. So let's kill it. So I'm good there. I am good there. That noise, it could be anything. I don't know what it is right now. Move you out of the way. I don't know what the noise is, but the next thing that I'm going to do is I want to look at the horizontal deflection to see if we're getting anything out of that. And that's going to be there's two more wires down here, red and white. So I'm going to put my scope on there, and what we should see there should be some sort of repping signal that indicates your scanning beam going back and forth. Well, not scanning beam, but it's just going back and forth to indicate, in other words, it's moving your beam of your oscilloscope, your CRT, to the left to right. So I've just got it on the horizontal plates right now. Let's find out if it works. Not really. See if I got this thing right. See, I don't see any scan. See, that should show a sawtooth type wave. Not seeing it. So vertical is working, horizontal is not. So let me get it reset up. Find that part of the schematic. Hopefully it's right. And let's find out what's not working in that time base.